Electricity is the set of physical phenomena associated with the presence and motion of matter that has a property of electric charge. Electricity is related to magnetism, both being part of the phenomenon of electromagnetism, as described by Maxwell's equations. Various common phenomena are related to electricity, including lightning, static electricity, electric heating, electric discharges, and many others. The presence of an electric charge, which can be either positive or negative, produces an electric field. The movement of electric charges is an electric current and produces a magnetic field. When a charge is placed in a location with a non-zero electric field, a force will act on it. The magnitude of this force is given by Coulomb's law. If the charge moves, the electric field would be doing work on the electric charge. Thus we can speak of electric potential at a certain point in space, which is equal to the work done by an external agent in carrying a unit of positive charge from an arbitrarily chosen reference point to that point without any acceleration, and is typically measured in volts. Electricity is at the heart of many modern technologies, being used for electric power where electric current is used to energize equipment, electronics which deals with electrical circuits that involve active electrical components such as vacuum tubes, transistors, diodes and integrated circuits, and associated passive interconnection technologies. Electrical phenomena have been studied since antiquity, though progress in theoretical understanding remained slow until the 17th and 18th centuries. The theory of electromagnetism was developed in the 19th century, and by the end of that century electricity was being put to industrial and residential use by electrical engineers. The rapid expansion in electrical technology at this time transformed industry and society, becoming a driving force for the Second Industrial Revolution. Before any knowledge of electricity existed, people were aware of shocks from electric fish. Ancient Egyptian texts dating from 2750 BCE referred to these fish as the "thunderer of the Nile", and described them as the "protectors" of all other fish. Electric fish were again reported millennia later by ancient Greek, Roman and Arabic naturalists and physicians. 2. Several ancient writers, such as Pliny the Elder and Scribonius Largus, attested to the numbing effect of electric shocks delivered by electric catfish and electric rays, and knew that such shocks could travel along conducting objects. 3. Patients suffering from ailments such as gout or headache were directed to touch electric fish in the hope that the powerful jolt might cure them. 4. Ancient cultures around the Mediterranean knew that certain objects, such as rods of amber, could be rubbed with cat's fur to attract light objects like feathers. Thales of Miletus made a series of observations on static electricity around 600 BCE, from which he believed that friction rendered amber magnetic, in contrast to minerals such as magnetite, which needed no rubbing. 5, 6, 7, 8. Thales was incorrect in believing the attraction was due to a magnetic effect, but later science would prove a link between magnetism and electricity. According to a controversial theory, the Parthians may have had knowledge of electroplating, based on the 1936 discovery of the Baghdad battery, which resembles a galvanic cell, though it is uncertain whether the artifact was electrical in nature. 9. A half-length portrait of a bald, somewhat portly man in a three-piece suit. Benjamin Franklin conducted extensive research on electricity in the 18th century, as documented by Joseph Priestley, 1767, History and Present Status of Electricity, with whom Franklin carried on extended correspondence. Electricity would remain little more than an intellectual curiosity for millennia until 1600, when the English scientist William Gilbert wrote De Magnete, in which he made a careful study of electricity and magnetism, distinguishing the lodestone effect from static electricity produced by rubbing amber. 5. He coined the new Latin word electricus, of amber, or, like amber, from electron, the Greek word for amber, to refer to the property of attracting small objects after being rubbed. 10. This association gave rise to the English words electric and electricity, which made their first appearance in print in Thomas Brown's Pseudodoxia Epidemica of 1646. 11. Further work was conducted in the 17th and early 18th centuries by Otto von Guericke, Robert Boyle, Stephen Gray and C.F. Dufay. 12. Later in the 18th century, Benjamin Franklin conducted extensive research in electricity, selling his possessions to fund his work. In June 1752, he is reputed to have attached a metal key to the bottom of a dampened kite string and flown the kite in a storm-threatened sky. 13. A succession of sparks jumping from the key to the back of his hand showed that lightning was indeed electrical in nature. 14. He also explained the apparently paradoxical behavior. 15. Of the Leyden jar as a device for storing large amounts of electrical charge in terms of electricity consisting of both positive and negative charges. Length portrait oil painting of a man in a dark suit. Michael Faraday's discoveries formed the foundation of electric motor technology in 1791. Luigi Galvani published his discovery of bioelectromagnetics, demonstrating that electricity was the medium by which neurons passed signals to the muscles. 16, 17, 12. Alessandro Volta's battery, or voltaic pile, of 1800, made from alternating layers of zinc and copper, provided scientists with a more reliable source of electrical energy than the electrostatic machines previously used. 16, 17. The recognition of electromagnetism, the unity of electric and magnetic phenomena, is due to Hans Christian Ørsted and André Marie Ampère in 1819 to 1820. Michael Faraday invented the electric motor in 1821, and Georg Ohm mathematically analyzed the electrical circuit in 1827. 17. Electricity and magnetism, and light, were definitively linked by James Clerk Maxwell, in particular in his On Physical Lines of Force, in 1861 and 1862. 18. While the early 19th century had seen rapid progress in electrical science, the late 19th century would see the greatest progress in electrical engineering. Through such people as Alexander Graham Bell, Otto Blathy, Thomas Edison, Galileo Ferraris, Oliver Heaviside, Ányos Jedlik, William Thomson, 1st Baron Kelvin, Charles Algernon Parsons, Werner von Siemens, Joseph Swan, Reginald Fessenden, Nikola Tesla and George Westinghouse, electricity turned from a scientific curiosity into an essential tool for modern life. 1887, Heinrich Hertz, 19, 843–44. 20. Discovered that electrodes illuminated with ultraviolet light create electric sparks more easily. In 1905, Albert Einstein published a paper that explained experimental data from the photoelectric effect as being the result of light energy being carried into space.